Simulation practices like video games, actually quite serious simulation. We want to know, like, in depth, with more truth, the handling characteristics of this airplane, and because we don't really understand how it is one aircraft that had so much success be so talked bad about by air.
First of all, about the aircraft, once it is in the air, it's beautiful, everything is very harmonized with the controls. The problem is takeoff and landing, and if you say the aircraft has no problem, why 33,000 Messerschmitts have been built? Exactly. How many aircrafts were destroyed without enemy? What is it?
I really don't know.
Okay, because it was a success. How many Bf-109 have been destroyed during takeoff and landing? 10,000. So every third takeoff was a crash.
Yes, I heard that.
And they had, in the beginning, they had round airports with crashes. We don't have these airports anymore. Now we have concrete, anti-skid, and we have always wind from the crosswind. So during takeoff and landing, this aircraft is one of the most difficult aircraft ever flew. The aircraft, you can imagine, you have about 12 centimeters. This 12 centimeters is 1,500 horsepower. So I go during the takeoff like this, and left of the runway done. If I go a little bit too slow, the aircraft starts working like this. Why? The gear on a Spitfire is like this, like on a bulldog or whatever. It's like this. On the Messerschmitt 109, it's like this, and like this. So every irritation, even if it's from my side or if it's from from the runway, ends up in a struggle. So this is what we have to compensate. So now you have these pedals. You give a little bit thrust, you have the pedals, and you put a little bit right pedal forward, you give a little more right pedal, you put the end. Now comes the tail up, done. Left of runway, aircraft correction. So you have to think in advance. So you have to keep a little bit, about 30% left on the right pedal, and the tail comes up, pull the right pedal, a little bit more when it lifts off. It's a single seater, we cannot train.
Not really. We know that armament is not installed, the weapons are not installed, and it has some ballast installed, some weight installed instead. How does the weight change the flight behavior, would you say, in comparison to the original? Would be the same? Absolutely the same.
You really don't. Of course, there is a difference, but it's not very magnificent. So
Yes.
it depends if you have full fuel or no fuel.
Okay, for the rest of the interview, we're kind of assuming full tank, like it's been refueled to the max. Like we were saying, the torque is very powerful, and we heard that the rudder has an airfoil shape. It's not symmetrical; it's asymmetrical to compensate for the torque. So, what's the other rudder controls and stability during a cruise flight? I would say an economical power. Do you have to apply some kind of pressure, or is it trimmed?
Normally, it's during cruise flight, you cruise with around 420-450 kilometers an hour. It's about 60% of the engine, 60% power. Everything is very balanced. The only problem is you have the coolers, the liquid coolers. They can open and close. Normally you don't do it in automatic, you do it by manual, and it depends, they don't go in the same direction. And it's 1 millimeter with 450 kilometers an hour, it rolls to the left. So it depends on your temperature, how wide the coolers are open, depends on the trim status. So the trim status is only for one status, so the engine gets a little bit hot, you have to open the coolers, and then it could be rolled.
I understand.
So you have to work during a ferry flight, always.
Usually on cruise, you will not be fighting with the rudders, you will not be 2 fingers on the stick perhaps?
No, not 2 fingers, you have 3 on the...
I'm talking about like trim, full trim, no active pressure, just...
Yes, you have active pressure, when the engine gets hot, you have to open the cooler, as I said.
Okay.
Then it rolls.
So, fine. about the elevator trim control. The wheel we have on the left, it shows +2, nose down, and -6, nose up, and 0 neutral. The zero position, this neutral position, what does it mean? Is this
Only neutral position is when it is in a shape and it is on cruise flight. When you have almost neutral, plus minus.
Pero posición es
okay? So during cruise, you will put it at 0 units. It will be 60% more or less.
80%.
80%. Okay.
And need push the stick with neutral trim? No? You can fly hand off?
You can almost be hand off in this axis, yeah.
Really? You can fly?
In this axis, you leave it neutral, and it flies through. 440 kilometers per hour
That's
is the
about
cruise.
the cruise speed, yeah.
440.
Kilometers.
Kilometers per hour, we're talking always. Yes,
Actually.
we don't do nuts here. Yeah, excuse me. So there's an English book about the Bf-109G, the Gustav Black 6, the restoration of the Black 6. Dave Southwood, the ex-test pilot for RAF, said that the Black 6 with the ailerons and rudder fixed trim tabs, the trim tabs that you fix on the ground, adjusted, the aircraft is stable to fly straight and wings level.
Correct.
So at
As long as you're not touching the coolers.
of course, yeah, like we said, at the 1 ATA, 1 ATA, or 2000 RPM. It's the same for Red 7.
It's the same. You fly with 1.05 ATA, or you have the cruise flight. If you go on long distance, you fly with 1.05 ATA.
At the 0 degrees of
That
trim.
is about 2,100 RPM.
Okay, thank you very much. So, when you increase the power, I believe the center of gravity is behind the aircraft. How is the aircraft affected when you increase the power? Do you have a nose up, nose down?
You have almost, because we do it always very, very slow, and to protect the engine, we don't really go above 1.3 ATA. So it's a minor change, and you don't feel it in a nick moment.
No problem. So you increase the power, you
The roll axis?
You have a little bit pitch up, a little bit, but then if you go faster, you have to trim about
1 inch,
half.
minimal. Is there any change in the rolling characteristic of the aircraft?
Rolling.
Yeah, when you increase the power due to torque, no problem, no? Okay.
The torque always goes in the direction of stability. It's
Yes.
always like this, but in the air you don't have it. You have it only on the ground.
Yeah. We would like to know the real trim configuration for takeoff in the 109 that you have. Like
You taxi out with full nose down because so full forward you taxi out because then you get a little bit lighter on the tail gear, and during takeoff you have it slightly up. So what is it? -1? No, +1.
+1 for takeoff.
Half is minus.
For, nose forward.
No, up.
Nose up.
That is the problem.
That will be
the rhythmic tails.
+1.
+1 then. Okay. I don't know where plus and minus is.
I know it's crazy. Yeah.
So aft.
In the G2,
Yeah.
in the Black 6,
In the G2, he said that he set the trim to -1.
Okay.
No, 1 degree nose up. That's what we're doing.
Nose
no?
up is
see,
same.
but this is correct. It's -1 degrees is 1 degrees nose up. Minus is see, angle of attack of the horizontal stabilizer. Yes, entonces.
Yeah, we just wanted to know if it's minus or it's plus.
British.
Because it's a bit crazy, no? It's nose up basically.
Yeah. No.
Yeah, but
So
Cloud
trim
Plaza
is
says heat trim +1, o sea, +1. What? ¿Por qué?
Pero
Why?
puede ser una equivocación. Could be
Because I have to go to the next group.
Yes.
I have my card here. I'm the chief test pilot of Airbus helicopters. And if you have more questions, perhaps
Yes.
I can answer it you via email. Is it okay?
On email, even better.
Perfect.